I think that we are live. So, welcome everybody to the stream this evening. Well, evening for me. It could be afternoon or morning for you, depending on where you are. Um, I'm David Hewitt, one of the team at Pydantic, and I'm joined here with Marcelo, another of the team. We're here today to chat about Pydantic Logfire, which is an observability product that we've been building for about 2 years now. We're super proud of it, and I'll tell you more about it in a second. We're also going to play around with Pydantic Logfire's Rust SDK to instrument Rust applications, and we're going to use OpenAI Codex CLI as an AI-assisted coding agent to make use of all that instrumentation that we're going to add to an application. So before we go more into Pydantic Logfire, a little bit about me. So I have been working for quite a long time to combine Python and Rust as like programming languages, make them interoperate and do cool things together. And so this is like a nice way to demonstrate how like Pydantic Logfire is built originally for Python, but it's also works fully for Rust with the Logfire Rust SDK, which I've been working on. So it's cool to show this off and see what you all think of it and give you the idea of doing this yourself. Marcelo, do you want to introduce yourself before we continue?
Yeah, sure. My name is Marcelo. I've been maintaining uvicorn and starlette on my free time for some time already. And I've developed the Logfire MCP server that we'll be using at some point in this life. And I'm also involved a bit with the MCP Python SDK development. And yeah, I've been working at Pydantic for 2 years.
2.5 now, right? We both joined when the company was created.
Oh yeah, 2 years and a half. Yes. Backend development, Pydantic AI, everything related to what we do here.
You say the fast API expert as well? I don't think yet.
Oh yeah, yeah. I'm also self-known as the fast API expert.
Super. Okay, cool. So Pydantic Logfire, it's our take on an observability platform. It's there's loads of these out there. You've probably come across other providers like Datadog or Elasticsearch, or indeed there's more stuff focused on like AI instrumentation, the new era like Langsmith. Our take on Pydantic Logfire is that we want something that's simple, figure and get started. It should feel straightforward to use, and so we've made it like a key design is that it's quick to set up. You can SQL to query the information that you get out of it, but we've also made it really quick to get. So it's something that's good enough when you're debugging your application locally, as well as then when you'll deploy it to production, deploy exactly the same. And I hope that that's something that you'll take away from today. We're going to be using from my local computer here, Logfire, to immediately see results up on the Logfire platform. There's first-class support for Python was the original language that we launched with. That's Pydantic as a company has come from Python, the open source software. Oh, sorry, Pydantic Validation, the open source software. So it's not a surprise that Python was where we went first. But we also have first-class support for TypeScript and Rust. But you're not limited to that. So Pydantic Logfire is built on top of OpenTelemetry, and OpenTelemetry is like a huge open standard which describes how to send information about what your application is doing while it's running and receive that in some other companion server. And so Pydantic Logfire implements both an OpenTelemetry client in its SDKs, but also a server in the platform that we provide to you. But OpenTelemetry, you're not limited to any one language really. There's OpenTelemetry SDKs for Java, Go, whatever language you can think of really probably has an OpenTelemetry SDK. So Pydantic Logfire will work with any of those languages. So our favorite languages, the ones that we've chosen first. Any more that you think I should add, Marcelo, before we proceed to talk a little bit about the Rust SDK?
I think you mentioned in the beginning, but the goal that we talked in the first week of development of Logfire was to be focused on developer experience, and I think we've been carrying that since the beginning.
Yeah, Completely agree. It's with great pride that I've enjoyed basically every day when I'm building Logfire. As like a Rust engineer, I've been working a lot on the database that powers it, and I've been monitoring that in Logfire itself, which is like a super rewarding like feedback cycle. I do that both locally when I'm developing it and when it's up running and tested. Cool. So here I am. The page that we've got in front of us is pydantic.dev/logfire, which has got some information introducing it. There's a big button Get Started, which we're going to click now. And it will take us through to the landing page to sign into Logfire. You get to choose your region. So if you want your data in the US or the EU, it may be important depending on your company. I'm going to go into the EU region, counties. And this is the landing page that we will get to if you log into Pydantic Logfire for the first time. I've already got a few projects in here. There's also a demo project you can view from the beginning to just see a quick run through of what Pydantic Logfire looks like live. So if we go through to here, then this is taking us through to the Pydantic Logfire live view. And what we're seeing is a demo app, which I didn't open. So we have just a small web app open here, just an example. Well, it's just generating a map and got a few pieces of functionality. But when people are interacting with the demo project, then it's producing information being recorded in Pydantic Log. So over the last few minutes, you can see a few different interactions. And we can see this was a webhook call that went back and we received it. It was fast API server, I guess, is handling this. Arguments processed. Oh, you need me to be louder. Okay. Thank you. I will try and configure that. How is that? Maybe a touch more. Okay. No, that maybe looks a bit high now. Okay, super. I've turned it up. Let me know if that's too quiet still. Thank you, Raymond, for letting me know. Okay, great. Let's proceed like that. Please do ping if it goes too loud or quiet again. So yeah, we're looking at the Pydantic Logfire demo project here. And these happened a few minutes ago in my time zone, 2 minutes, 17:07. And if we click on any one of these events, we get some information about, that's not a very interesting one, but we can see some Postgres query going on. Perfect. Thank you, Raymond. Which has information about, say, a database query, and then some extra information about the system that was running. I don't really want to dive too much into the demo project because we're going to go use a lot of Pydantic Logfire in a second, but I just wanted to do this to show you what's going on. So let's go back to me, my organization, and instead we can create a new project here. So we'll create a project called Hello YouTube. And once we've created it, what we're greeted with is some instructions about how to get started to send data from your own application to Pydantic Logfire. It's actually got the Python SDK here because that was the platform that we built first. So we'll need to talk about the Rust SDK now and how to use that. So I spoke previously about how Rust or OpenTelemetry has lots of different languages which it has implementations for. And so Rust is no exception. If I go to docs.rs, the standard documentation site for Rust, and go /OpenTelemetry, I end up on the landing page of the OpenTelemetry API crate for Rust. So the standard piece that you'll install probably if you wanted to start using OpenTelemetry instrumentation in your Rust code. And this totally works. When we began using Logfire, we had an example on the Logfire documentation which showed you how to use Pydantic Logfire through the Rust OpenTelemetry crate because we hadn't produced the Rust SDK at that point. But the downsides of using the OpenTelemetry SDK directly is that there's potentially a lot of complexity for you. It's designed to give you a lot of choice because there's a lot of different potential scenarios that you might want. And our Logfire SDK helps make that easier. So for Rust in particular, there's one piece of the system which you might care on top of OpenTelemetry, which is another package called tracing. So if I go to the documentation for tracing, just to briefly introduce it, tracing is a related piece of the ecosystem, but it's not directly built for OpenTelemetry. So it's a Rust package that's kind of like the main abstraction that people use when they want to do logging and tracing in the way that we saw like in the Logfire demo project for Rust applications. So it provides methods like, or macros like creating a span or creating an event, which would be a log, like an info level log if you like. And you can use these to, say, produce a logging stream that would write out to a file or to your console or wherever you really want them to go. And tracing has lots of integrations built with it. If we scroll down all the way to find those, yep, here they are. And the most important one that you might consider if you were working with OpenTelemetry is a piece called Tracing OpenTelemetry. And again, if you want to use the OpenTelemetry SDK to configure where you're sending data yourself, then you can use tracing with it and tracing OpenTelemetry as the piece to glue the two together so that the instrumentation you write with tracing will end up being sent by OpenTelemetry. And that works totally fine, but it's still quite a lot to configure. So that's why we built the first class SDK for Rust. So docs.rs/logfire, you can find this. And this is our take on having a really quick setup to just get running with Pydantic Logfire. And so I want to show you this now. We'll switch over to VS Code, which I've got over in the background. And we can create, I've got a checkout of OpenAI Codex, which we'll talk about later. But before that, let's create a new project. It will be just a quick application. And we'll call this new library, maybe Hello YouTube, why not? So we'll go into this and I will add that folder to my VS Code workspace. Great. So now we should be ready. And if we look at the files that we've got, so we have the standard skeleton of a project that Cargo will give us if we're creating an application. So we see a main.rs file and a cargo.toml file, which describes the dependencies. And we could just go and compile and run this now. It won't do very much. It just prints hello world because that's the sample application we've got here. So let's go back to the Logfire documentation and take our sample main that's from the docs. We're going to paste that in and talk about it in a moment. We can just run cargo add logfire to immediately add logfire into our project. Great, with that done, we can launch this off. Oh, no. Oh yeah, we can, it's fine. We've got to compile to run first for all the new dependencies we pulled. Okay, so while that's running, what does this demo do? Well, first, we're doing our one-shot configuration for Logfire. It's as simple as just calling Logfire configure will give you the defaults that will work sufficient to send over to Logfire. It will connect up tracing and also another crate from the Rust ecosystem called log, so that all of these will be sending over OpenTelemetry. we introduce a guard. If your application crashes with a fatal crash called a panic in Rust, then it's possible that your application won't get a chance to shut down cleanly. So by introducing the guard, if there is such a crash, we still get a chance to send the information over to your server before the application quits. And finally, we then log out using the Logfire crate, just a hello world. And so, okay, that's finished. And we see the hello world. Oh no, that I did not save the main. I'll have to run that again. My mistake. And this time we get an error saying the token is required. That's because we haven't logged into Logfire yet. So with our Python SDK for Logfire, we also provided a command line application to do the one-shot configuration, setting up projects and authentication and things like that. And even though we're using the Rust SDK, we can still use the Python SDK to configure our project for development here. So I'm going to use a command runner called UV, and specifically UVX. UV is a packaging tool for Python. And if you name a Python package, you can pull straight through from the package index a command line application and run it. So we'll do UVX Logfire. If you wanted to set up Logfire for the first time, you could do auth, I think it's called. I've already set this up, so we don't need to do that. But what I can do is I can do projects use, and we called our project hello YouTube. So that's now set up. And if we run cargo again, then this time it's run. We didn't see anything, but if we go back to our demo project, which I'm going to have to go find. Here we are. Hello, YouTube. Then we now have that log message on the Logfire platform. And let's just play around with this demo a little bit further before we start instrumenting a real app. So here on main.rs, we're just going to talk a little bit about what we can do. So we saw that like nested structure, and we can introduce that through spans. So and if you're familiar with tracing, it might feel very familiar how these work. These macros more or less wrap tracing spans, but add some extra nicety in the syntax, which I'll show in a second. We can do this, and then we talked about a crash. So let's add a fatal application crash as well. Something went wrong. So if we save that, I'm going to do one last modification, which is I'm going to enable console printing. The default console options will be fine, but with this, then we'll see the output coming to our terminal, as well as going to the Logfire platform. Let's run again, and here we can see, so we entered first the span that we created, doing some interesting work. We printed our info log, and then we had the crash. And if we look over on the Logfire platform, what we see is that same structure. We have a span, and if we expand it, we first got to print hello world, and then we crashed. Now, one more cool feature of the Logfire crate macros in particular is the way that we've flavored capturing information in them. So you might have some variables here, like x is 42, and y, I don't know, maybe it's 0, or something like that. And we can actually capture these. And this might not look like anything too interesting if you're used to how Rust formatting macros work. But the cool thing is what we then see on the Pydantic Logfire platform. So this time we'll run it. And you can see that the message we printed contained the formatted values. X is 42 and Y is 0. And if we go onto the Logfire platform, we get that. But even cooler, you actually see the values that came through got recorded as well. So you can use this to capture information about more interesting things that's running in your application. Okay, great. I think that is probably enough for a quick introduction. for how this works. So now let's go play with a real application. And the real application we're going to play with is going to be OpenAI's Codex CLI itself. So for those of you who aren't aware, I've already got the checkout here, and OpenAI Codex CLI happens to be implemented in Rust. The main loop of the coding agent is a Rust program, and so I've got it running locally. I can run it like this. I'll just check I've got it ready to go. Yep. And so I'm now running a local development copy of the OpenAI Codex CLI. And not really anything remarkable about this local copy yet. It is just a local copy of what you'd otherwise be able to install publicly. But the cool thing is that OpenAI Codex is actually instrumented with tracing. So if we take a quick look, what we find scattered throughout the OpenAI Codex codebase is lots of uses of tracing's logging macros. And OpenAI Codex is using these to create logs, I think, that just go into either the terminal UI that we see when you run it, or I think they go to log files as well. And so we can find that if we search for tracing subscriber, which is the piece that configures everything. We find it here. And by setting a tracing subscriber with 2 layers, we can see there's a file layer and a terminal UI layer. That's setting up output from tracing macros for OpenAI Codex's case. And as I discussed, tracing is this like super flexible component that can do a lot of different use cases. Here, it's not concerned with OpenTelemetry at all at the moment, but we can add that. And so how we're going to do this, we're going to need to add Logfire as a dependency of our local copy of OpenAI Codex. So we can go to the cargo.toml, we'll just add Logfire, and the latest release is 0.8. And we will go back to wherever we just were. Here we are. And we can add another layer to our tracing infrastructure, which will be our Logfire layer. I don't think we need the console output this time. We'll do Logfire configure finish. And then we're going to add in here, Logfire, once set up, has a tracing layer that you can use if you want to add it to an existing application rather than configuring it for its like own base defaults. But if doing that, you're actually going to have to set this up as a local mode so that Logfire doesn't try and set up its own tracing globals first.
David, why do you run the finish? Like dot finish? Online 220.
I've got double sound from you, Marcelo. Or are you muted? That's better, yeah, sorry.
Sorry, it was me.
Sorry. Without the double, can you ask the question again?
Yeah, you have online 220, like the finish at the end. Why do I need the finish at the end? Like, why not dot configure only?
Yeah.
Oh, sorry, my audio is cut out.
Yeah, I think it's okay now. I think Marcelo's audio should be back. I paused it while I was having some trouble. But now that it's clean, I think the audio should be good to go. Let me know if there's still any problems. Otherwise, I think we can continue. So yeah, Marcelo was asking, why do we have to finish rather than just call configure? So configure is giving us like a setup, which then gives us an opportunity to, in Rust, it's called a builder pattern. So it creates a Logfire config builder, And then that has lots of options for modifying what goes on. So in Rust, we don't have keyword arguments in the way we do in Python. So a typical way to get like a keyword-like functionality is by first returning a structure, which we'll call a builder structure, which has lots of methods to set things on it. And so these are all the different options that we allow you to configure in Logfire if you don't want exactly the default. And then once you're finished, typically you call finish on a builder so that you can complete the configuration. Okay, we're getting an error on the question mark. That's probably because the function we're in isn't compatible with Logfire's error type. Rather than worrying about that, I'm just going to add an expect. And trust that everything's going to work. Okay, super. So with that set up, we should be in a point where OpenAI Codex is ready to be instrumented. We'll need to, in this folder, also tell it what project we're going to use. So UVX Logfire projects use hello YouTube. And now that that's set up, let's run Codex. What we should find is that in our hello YouTube project, once the compile finishes, which is going to take a moment or two just while the additional pieces get compiled, once it launches, we should see some initial logs come through. There we go. Okay, these don't look super interesting. They're just saying registering event source. I think they're probably something to do with the fact that the terminal UI is just starting up and is probably handling user input. One other thing, it currently says unknown service. Let's just make that a little bit cuter. I'm just going to quit out of this. So, for example, Marcelo, one of the things that we can add is we can set a service name directly as one of those builder methods. And so now when we run, we should see the service being called Codex instead. Let's go run this. This time we will ask a real question of OpenAI Codex. Great. So here we are. Chat, feel free to suggest things that we can ask that the AI will give quick responses to. For now, I'm just going to give it some really basic maths questions and see whether it can get the right answer for me. But anything that you think the AI can answer in one shot for now will probably be good for the next phase of testing our Rust application.
By the way, we are running on GPT-5, right?
I believe so. It's whatever the default model for OpenAI Codex is, which I suspect at this time is GPT-5. It was remarkable how the thinking got to 0 quite quickly, and then it continued to think for quite a while to give us the final 0. But there we are. So over in our project, now what we see, we compiled this time with Codex set as a service name. So everything from here on down is what's just happened to go complete our AI agent request. And there's a ton of stuff going on, actually. We see some messages about MCP, which we'll talk more about later. There's maybe this looks like an HTTP call that's being called. It looks like OpenAI Codex is checking what our current platform is. And then there's some streamed responses coming back. Quite a lot of before it looks like it finally completed. So as you've noticed, it's all in one flat line, flat stack. There's no nested structure like I showed from the demo project. And that's not a surprise because, as we said when we first looked at Codex, it's using tracing's logging macros, but it's not using tracing's span. So it's not creating any of that nested structure as the application's running. So I think that the next thing we shall do to make this information coming out here a bit easier to interpret is we'll try and identify some of the interesting things going on and add some structure to this application so that we can see what's happening. So looking around, let's pick out actually this one that we've already clicked on. Seems like one that happens quite frequently, the SSE event. So that will be data coming back streaming from OpenAI's API returning, it looks like maybe thinking or final tokens. And one of the great things about OpenTelemetry is that you can capture by default the file and line that message is being logged from. So here we can see the file path is client.rs and the line number is 422. So let's go back to VS Code, start there, and work out from line 422 what's going on. Here's the log message that we saw. And see if we can add some structure. So it's inside a function process SSE. And the tracing, right, which is being used by OpenAI Codex, is what we'll continue to use here. And that has a procedural macro. It's an attribute that we can add. It's a bit like for people who are more familiar with Python, there are decorators. And indeed, our Logfire Python SDK has a Logfire instrument decorator, which you would apply to a function. In our Logfire Rust SDK, we haven't created an equivalent macro attribute yet. It's a relatively big implementation piece that, I mean, we totally could do, but the tracing one also works very, very well. And so maybe in the future we'll have one, but for the moment, tracing one is a perfectly reasonable thing to use. And indeed, we've added Logfire to one piece of the Codex codebase, but not the whole thing. So it's just easier to use tracing for now anyway. Tracing, by default, it's going to try and capture all of these arguments. I don't think the stream or this channel for sending the result is going to be very interesting. So I'm just going to tell it to not capture those arguments, but we will let it capture the idle timeout. Now that we've added this marker, we can go back. We're going to stop and recompile and run this one more time. So let's see. Once this is finished, great. So we haven't had any suggestions for silly questions to ask the AI yet, so I'm just going to ask it increasingly complicated maths questions. Marcelo, if you've got any other ones, then I'll take your suggestions as well. Otherwise, here we go. Let's do this one.
How many hours are in Strawberry?
Oh, the classic one. Okay, yeah, we can do that next. The next time we need to ask the AI something to see the trace, we will do that. So we have now got in our latest telemetry, which must be this burst here from 5:33. That's the time that we've got now. We can actually see it. We now have the process SSE span, which got created by that tracing instrument macro. And inside of it, we now have all of the SSE events. So we've begun to add some structure to our program, but there's still quite a lot going on that we haven't given structure to. So let's just iterate on this a couple more times to get the structure. But before we move off, I mentioned that the idle timeout was the argument that we were going to capture from process SSE. And you can see here in the attributes that we captured, as well as some default things which have come through, like the file and line that this was applied to, we've captured that idle timeout variable. But because this was done through tracing rather than the Logfire macro, it hasn't come out into its own section. Right. So with that done, let's just identify a few more of these that would be interesting to go for. Let's see. Running text writer. Oh, that's come from a dependency of OpenAI Codex. It's not self one, but we can see if we can find this. So let's see where TUI Markdown is used. Only used in one place. That's convenient. Append Markdown. This looks like a totally reasonable one to mark. Tracing instrument. And let's just skip all of these variables. I'm not sure what they are. Maybe the lines looks potentially interesting, but we probably capture that by other telemetry. So with that done, let's just have a look, try and collect some other ones that look interesting. So there's some stuff going on here related to the operating system. Oh, that's again actually a dependency. This time it's OS info. So let's search for OS info and see if we can find where that's called. That's called from, yeah, it must be one of these, I guess. Get codecs user agent. Oh yeah, it's only called once. So let's just add tracing instrument on here as well. I think the originator looks like something that can't be that complicated. It's just a string, so we'll capture that. Maybe one or two more to help us get some structure, and then we'll try this again and see what it looks like. Because yeah, I think all of these messages have come from OS info. So hopefully by marking that one function, we'll capture those all together. Where's this one go? The HTTP post, that's probably a good one to capture. That's in the Codex codebase itself, client.rs line 183. So we can go, oh, we already had client.rs open. Line 183. Here we are. That's in a function called stream responses. So let's add tracing instrument on here too. Prompt is probably cool to capture, but it looks like self might be too much. It's given us some red squigglies. Yep. Okay, so we can capture the prompt, which I think will be interesting to see, but the full client that this is part of was too much to capture because it didn't implement a Rust debug macro, as it's called. Okay, so we can now, let's run this at this point and see what we get. We're going to count the R's in strawberry this time. Okay, so how many in... So we hope we're going to get the answer 3, though I'm told that AI are notorious at getting this one wrong. While that is busy thinking, what we should see live now is, yeah, we have some process SSE work ongoing, and it looks like it's finished. So here we are. Oh, yep, it's given us the right answer, which is
I'm going to
good
Google
news.
difficult questions for AI.
You're looking up some difficult ones. Sure thing. We'll at some point we'll turn the AI agent to the code itself, but we're still kind of getting the shape of what's going on. I think it's looking better, but the span for where have we got? We could possibly go here and find what's going on here, this handle codecs event. And then I was expecting the SSE stuff, the events, to probably be stacked inside of stream responses. So maybe we should find that. And then maybe also we've got something about recording items for conversation. Will I publish this fork? I can, Raymond. It will have just a few very light modifications to it. But it seems like a totally reasonable thing to do, so that you can see I'll push it, there'll be one commit on top of whatever the current main is that I've pulled. And I would be surprised if this actually ever got merged back into OpenAI Codex, but it's probably, hopefully then that commit will serve as a useful reference if you wanted to do something like this yourself. Okay, so yeah, let's go find the handle codecs event call in chat widget 624. Okay, so that's sending the message, and then it's doing something with that. I think it might be interesting to just put it directly on this. probably group a few things together. And then let's, okay, find recording items for conversation, codecs to RS line 360. That's in a function record conversation items. Wait, codecs, modify codecs to talk to we aren't going that advanced with codecs, as in we're not going to modify codecs substantially, but we're just going to add the tracing, and then we are going to do some interesting stuff once we've got that tracing added. So, okay, there's a function run task here. This looks like a good one to instrument. Maybe we'll skip session sub ID, but input looks like an interesting thing. Refuses to spell code correctly. That's a good fact. And then the final thing is we want to get process SSE properly inside stream responses. So if we go search for process SSE, it's called from, these are presumably in tests because they're lower down in the file. Yeah, used in tests. So this one is the relevant one. And the thing that we're going to see here, which is what I'm not hugely surprised to see, is that this process SSE call is wrapped inside of a call Tokyo spawn. So to explain what's going on here, process SSE is an asynchronous function. We already previously saw it. And that means that calling process SSE like this here doesn't actually do any work, but it creates a future which can do work later. And you would normally just like .await it to do the work in this function directly. But if you want to send that work to go into the background, rather than be part of this function directly, you will spawn a new task. Tokyo is Rust's de facto async runtime. So using Tokyo to spawn a new task is pretty much like the typical way that you would spawn an asynchronous task in Rust. And when you do this, you unfortunately lose the context of the current task that you were in. So all of that instrumentation we added to stream responses isn't carried through to process SSE by default. And that's a little bit unfortunate, and it's just a consequence of how the Rust ecosystem is currently wired together. In the Python SDK, I think it does work properly, and that's because in Python we have a thing called context vars, which allow asynchronous tasks to store state. Does that sound right to you, Marcelo? I'm pretty sure I've got that correct.
Sorry, what did you ask? I was actually checking what Raymond said. My codex is calling Claude.
All right.
Sorry,
I
what
see.
did you ask? Yeah.
Just that in Python, if you're creating an asynchronous task and you spawn it from one into another, you get proper structured concurrency with context variables, I think. So you get inheritance on the actual variables from the tasks. I'm not like super clued into that depth of like Python async context vars.
You inherit from the parents, don't you?
Yeah,
You
I
do.
think so. I think that's exactly the point I'm making.
Yeah. It just the problem is usually the siblings. Yes, that's
Yeah. Yeah, that would make sense because I think you get like a clean copy, and so siblings won't share context. But yeah, so in Rust we don't have like a default context vars thing yet. I think as far as I know, there might be a crate to do it, but I don't think it's something that comes into the ecosystem by default. Maybe one day we will. But for now, that means that this task is completely isolated from the parent. But fortunately, there's actually a helper function we can use from the tracing crate, which will attach the current tracing span to some future that you've created. So we can do it just like that. And that should now lead to the proper nesting we want. So hopefully, if we quit out and compile, so make codecs, modify codecs, talk to Claude about the android. Well, to try and get ChatGPT to spell Claude code, maybe we'll ask what is Anthropic's AI coding agent and see what it says. And
that's what I was playing here.
I see, yeah. All right, well, while that's running, what we should see with this run of our trace, okay, so we now have a much more detailed one run task. We can see there's a lot of events going on, maybe too many. Maybe that was a bad thing to instrument. We have run task, and we have stream responses properly nested inside it. And then finally, we have process SSC inside that. So that's looking pretty nice now for seeing the structure of our application. And yeah, okay, tons of those events as well. Lots of detail, but that's cool to see. And then it's given us a summary. Oh no, it spelt it correctly. Stored code. There you go. Oh, but you said during voice to text. Okay, fine. So maybe it's not surprising that it's going to at least print it correctly with text. Yeah. So we haven't made the modification, we haven't committed yet, but let's do that because that we're now at a point where I think we've got enough instrumentation on our application. So yes, let's do observe changes since git head. What has been added?
Da, da, da.
Yeah, the moment of truth. But it looks like it's run quite a few different commands. Okay, so it's told us what's been modified, but it wanted to stop there. We'll prompt it further. And all the meanwhile, we have got, that's still from a couple of minutes ago. Let's go live. Oh, we really shouldn't have instrumented handle codecs event. That is super noisy. So we can see it's got one. It's then actually, so we here watching the application work, you can see it's doing some stuff with Git and making some decisions, doing some thinking. Each time it's getting a response from the OpenAI API, maybe with some stream. It decided, say, here to do a bash command, another bash command. Nico, that's an extremely meta one, and I have no idea what OpenAI Codex will respond to that with. We can definitely try that. So yeah, another function call. This is every time it's doing a function call, it's deciding to do something with still Git, but then the response that it's getting, it's going to be sending back to the OpenAI server to decide what to do next with it. And this is going to run for quite a while. It's still running. And in the meanwhile, we can see it's basically looking at each file in turn. Okay. It thinks it did the work. That's rich of it. Added tracing annotations, made updates to the cargo log file. Notable change includes adding the Logfire dependency along with its transitive dependencies. I'll examine a small chunk for Logfire integration. Fine. Resuming the current span across Tokyo spawn, so it's picked up on the interesting case there, and adding the telemetry into the TUI. Okay. It's given us a lot, probably more than we wanted to know about the things that we just did. But here we are. Okay. So yeah, so that is now an AI coding agent just analyzing the repository in question. The next thing to do will be to actually start making some modifications. But before we do, I want to introduce one final piece, which is MCP. So if we go back to our browser, I want to just load up
Do you have any MCP server already running on that codex?
I think I should. So we'll come back to that in a second. So we should talk about what MCP is very quickly. MCP is like a really generic protocol that's designed to allow AI agents to receive instructions basically from the MCP server describing what's available. That's the context. And in particular, the context will describe things like tools that the MCP server makes possible. And so the tools that we have added in a Pydantic Logfire MCP server give the AI agent the opportunity to communicate with Pydantic Logfire. And when I was speaking earlier, I mentioned that Pydantic Logfire is designed to be easy to get data from. You can query your own Pydantic Logfire data with SQL. And so the AI agent can do exactly the same thing. And that's kind of neat because it allows us to then debug whatever application we've instrumented and do some cool development work with it. So to illustrate this, we'll just have a couple of quick examples that will capture some of this instrumentation and use the MCP server to get an OpenAI agent to communicate with itself, with Logfire, and see the instrumentation on itself and identify some bugs. So I'm going to quit out of this session because we've already made the AI agent quite aware of what's been going on. And by quitting out, we're going to clean that so that we don't corrupt or give it any hints. So it's now running a fresh session. And actually, I'm going to we had a lot of verbosity on that, a couple of things in our logs. So I think, what do we have? We had this handle codecs event was like super busy in codecs TUI chat widgets. So what we can do is there's a standard environment variable called Rust log, which we can use to set the verbosity which we want for the instrumentation that we're getting. And Logfire will respect this. So we can set to capture everything by default if we go for trace level, but we can turn this particular log off. And there was also all this stuff from Myo, which looks really noisy. So I'm just going to do Myo is off as well. And now let's do that. And hopefully we're going to get a much simpler trace to read. And so this time we're going to ask, do you have a connection to Logfire? And the AI agent should be aware of the MCP server's context that's providing it instructions. And we can see now our new tracing, which, yeah, it looks a ton cleaner, right? It's just this stuff running maybe here. So the append markdown stuff is still quite noisy. Maybe we should turn that off as well. But run task, we now get, there was just one response this time, and it says, yes, I have built-in Logfire integration. And it says built-in, really what it means is that it's got the MCP server connected. As far as the AI agent is aware, it's got that in the context. So let's just pick a new, okay, so we're going to do something interesting with this. We're going to need to add something we actually want the AI agent to do. So let's, I'm actually going to switch to a different project so that we've got a bit of a cleaner context rather than having like all this stuff that we've been partway building. We'll get to a real clean slate. So projects use, and I've got one codex, which I was using earlier, which as far as recent data is concerned, is completely empty. Great. And what we're going to do is let's introduce some like bugs, if you like, to OpenAI Codex. We can't do anything too serious because if we actually add like really breaking bugs, then we're going to have some trouble because we won't actually be able to use OpenAI Codex to do any interesting development. But let's go just into maybe process SSE and let's just sneakily add a sleep. We'll do a 5-second sleep. And let's go to something else that we instrumented. What else did we instrument? Oh, we need to just quickly go back to the other project to jog my memory. maybe inside process SSE. Let's add something in process SSE. Oh no, we're already there. My mistake. Run task, maybe. No, that only gets run once. It's not going to lead to a very interesting response. Maybe stream responses. Okay, and maybe in here, let's just pretend that we've got an error that's firing. And you can imagine in production that this is going to be triggering some like alerts in your system because you're getting error messages sent off. And this might have been somebody in development that just like innocently left it, like me right here. And now, oh, hang on, we can't use Logfire because we're not inside the TUI crate. We can use tracing. Great. So let's launch for one last time Codex. We've made a couple of modifications, so we'll need to recompile those pieces. And this time, let's try and give some instructions about what's going on. So I have an application recording the Logfire. It has performance issues. Please monitor the duration of all data in Logfire and help me identify the performance issue. Or monitor is probably not a useful verb there, is it? Examine. Remember that because this trips up the AI agent a little bit, I like to remember to remind it that duration includes time spent in children. Also, so we added an error. Let's number these question requests. So 1 has performance issues. 2, there's an error which keeps being alerted. Can you please identify it? I'm just going to remember that we didn't change. Did we change the project? I did change the project, didn't I? Yeah, we're good. There's an error which keeps being alerted. Can you please identify and fix if possible? And then finally, what was that span that was super verbose? It was like handle markdown or something. Oh, append markdown. Also, this append markdown log is super verbose and I don't want it. Please get rid of it. Right, that should be enough work for the AI agent to do. So we will kick that off. And hopefully this is where we trust in OpenAI doing, or the AI agent actually doing what we hope of it. It's going to start talking to Logfire to understand what's going on. So it's going to be working on this for quite a while. While we're there, we should have the project going in Logfire, and we can see we've got super verbose text error. We can see, I think we added the sleep in process SSE, and you can kind of, it's very, very small on my screen, but if you can see it, you might just spot that there's in the waterfall showing how long stuff is taking, there's a gap, which is our sleep. So hopefully we'll find that. And then we've obviously got this append markdown log, which we've called out as a nuisance. So we're going to have to wait for that to complete for a moment. I remember that what I should have mentioned is just briefly how, while that's running, I will start a new terminal. To configure the MCP server, first off, you'll need a write token, or sorry, a read token to Logfire, which I set up earlier. So if we go to read tokens, you can see I created one codex, which I saved into my system. But you'll also need to modify the OpenAI Codex configuration to use your MCP server. So the way that you'll do that is, first off, Pydantic Logfire MCP server has instructions on how to run it. In general, you want to do something like use UVX to select Logfire MCP and your read token. And all of the different AI tools have basically some configuration file where you'll put this information in. And for OpenAI Codex, we can find this on their instructions. Search for MCP, here we are. So it wants us to add it to codexconfig.toml, the command. So in this case, it's UVX. And we're just going to put Logfire MCP here with a second argument, which is the read token. We don't need any environment variables. And so I'm obviously not going to read the file here because I don't want to show my read token. But the file exists. I set it up earlier to tell Codex how the MCP server should be connected. In the meanwhile, Codex has gotten to a point after a lot of thinking where it's identified. So what's it done? It's done some search. It's implementing code fixes. It wants to remove the error, the sleep, and the attribute. So it's found them all. And if we just read up the conversation history, you can see what it's done. So it's found error level records, and it's noticed the supervised text error or test error. So the thing that we added. Let's see what it did for performance. It noticed that process SSE is taking a lot of time, and picked out that the grandchildren don't quite add up, so it's got suspicious. And looking at the code, it then found the problem, and then it also we called out a pen markdown, so it could just search for that and find it. And so now it wants to apply a patch, and we'll just allow that. So it's removed the error, it's removed the sleep, and it wants to remove the instrument macro. So that's now all fixed up, which is kind of awesome. So we don't need to do anything else there. That's great. And we can see that also through our instrumentation, right? We had, well, here's the steps back here though, where in these pieces, when it's processing, I'll get this to load. I don't know if we can see anything interesting. Actually, it's quite hard to see the thinking inside all of this huge stream of data, isn't it? But the point was that it was able to use all of this information connected through Logfire to then do debugging. And we've obviously done a bit like full circle here because OpenAI Codex is modifying OpenAI Codex. But normally you might have OpenAI Codex running as a companion to edit your own Rust application. And with Pydantic Logfire, you could have an issue which runs in production, and you could immediately ask OpenAI Codex to go find that issue, locate it in the code, and propose or write a bug fix for you as you prefer. I think with that, I've shown you everything that I wanted to show today. So it's a good time if anybody's got any questions. I'll just allow, I think there's a bit of delay on the stream. I don't know how long the stream chat is. So if anyone's got any questions, I'll hover around for a couple of minutes, and then we might wind the stream up. So Marcelo, before we finish, do you think there's anything else about like MCP or what we just did that you want to point out or ask about?
The MCP server is in continuous development. I suggest people try it out. If people are not already using Logfire, try it out. And we are on Slack to help you to integrate in case you are not using it yet. And yeah,
Yes, that's a really good point. We have if you go through to get started with Pydantic with Pydantic Logfire, you'll immediately see there's a link to our Slack at the bottom in the middle of the page. And so if you're trying out Logfire for the first time, or you want to ask us questions after this stream ends, then please come join us on the Pydantic Slack. There's a Logfire channel, and you can join there and ask us what you like, and hopefully you'll have fun getting started with Logfire. Great. I haven't seen any questions come through. Maybe I'm just not giving enough time for the stream delay, or maybe I've answered you all with a good demonstration already. So thank you very much, everybody that's watched today. Enjoy the rest of your day, and we'll wind up there.
Thank you. Bye-bye.